Hello and welcome to the GCP lab of today's video. And today we're going to be doing Infiltrate GCP via web app exploitation. So get your web app exploitation socks on because we are about to launch Burp Suite. All right, so whenever there's an IP like this, we got to make sure we have the VPN file downloaded and OpenVPN turned on. Now, I already did that. So right here, my VPN is on. And I nmapped before the VPN got turned on. So let's go ahead and retry that. Okay. Let's try. Oh, see, yeah, it's working. It's clearly a web application. At least port 80 is on because we can see this web app. Now, there's one other tool that I wanted to use as well. I go to my GCP tab, over to the tools. IP to provider. Let's see if this bad boy works. So basically this tool is supposed to tell us if the IP is from GCP. And it didn't work again, so I'm going to completely remove this tool. But I mean, if we go who is, you can see Google right there. So basically in terms of enumeration, I guess that way we can know that this is a GCP instance, a compute instance virtual machine. But anyways, let's see what this inventory folder is about. Amazing. So username should not contain a space and special characters. Interesting. So all right, well, since we have a web application, let's go ahead and use fuff and see if we can fuzz for any pages or exposed pages that we're not supposed to access. So I'm going to be using this backup files only word list. If you don't have a, go ahead and get it from GitHub through this URL. And yeah, let's go ahead and get this. So if you're not familiar, we're going to use fuff to fuzz right here and see if the inventory directory has any more pages that we can catch. Header PHP back. Not the most fruitful, but let's see what other. Oh, right here we can fuzz for bucket files. This bucket word list is quite nice as well. Actually, that one is too long. Okay, so we're going to use this bucket word list, which I'm going to show you on GitHub. And we're going to add the extensions through the -e flag. We're going to add PHP, backup, log, and .sql. Okay, let me go ahead and show you this file. Buckets word list. This is literally how I found this word list. AWS S3 bucket word list. I actually did use this for AWS as well. But It's a very neat list. It's this one, not the common S3 bucket names. It's the list.txt. And it basically just has a bunch of common names for buckets, but names for buckets are also commonly used for many other things. So that's why I'm using it. Okay, amazing. We got a bunch of stuff. So backup.sql, script.php, login.php, and header.php. So let's go ahead and check this backup SQL out. Okay, looks like we got an SQL configuration file. Let's see if there is anything. Okay, so we have the columns of the table customer, inventory. So technically this could all be used for valuable information for injection purposes. Product. Oh, okay. We actually have actual data with the real files that they're using. Look at this format of the images as well. It's numbered from 0 up. Now, I don't know if vulnerabilities or disclosures could come in the form of images, but if we had an IDOR of like page or image 50 disclosing like personal photos or something, who knows? Sales table. Okay, so it looks like the, knowing this table has 4 rows. If we found a functionality which accesses this table, we know how to inject it because we know the number of columns. I mean, okay, actual hashes. So we have some actual password hashes right here. So let's go ahead and take these bad boys. Open a new tab. And paste these hashes in. And let's get the cracking. All right. Okay, so one of the hashes did appear to be cracked to retail 123. So knowing that, let's go ahead and check which one that is. Seems to be a user who we got the password of. So let's go ahead and copy that and enter the application. Wait, I want to see something. Invalid input. What? Invalid input. So the errors don't seem to be that well for username enumeration. All right, we are in. Now we can choose from a catalog of computers and iPads. This looks funky. So let's go ahead and check this out in Burp Suite, shall we? Lots of stuff here. Look at this. Search result 2.php. Very interesting. Let's check it out in Burp. All right, so the first thing that you want to do in this guide to Burp Suite is go to your settings, go to user interface, display, and turn on dark mode. Also increase the font size if you want. Much better. All right, let's turn on the Chromium browser and check this website out whilst our proxy is running. All right, let's see what's going on. Post request to the login.php, quite standard. And here's the source code of the page we're on. Any comments? Any storage? Google. Okay. All right, let's see what happens when we intercept some of these search blank. Wow, look at that. Uncaught MySQL SQL exception. Check your SQL syntax. Okay, so what we're going to do is let's go ahead and take this, what we just found, that there's an SQL database. You know, as per the SQL file, that configuration file that we found, throw that bad boy into repeater. Let's also save this, copy to file. Okay, let's get sqlmap on. Okay, whilst that's running, let's go back to our burp sweep. We did send it to a repeater. Now let's add in a few manual injections and see what's good. Different number of columns. Okay, so we use 6 nulls. Let's perhaps use 4. Different number of columns. All right, let's try a different endpoint. Keep testing the others, if any. No, just search. Unable to connect to target URL. Interesting. Let's see any other one. Fetch cart. Fetch cart 1. Perhaps that could be injectable. Minus cart. Let's go ahead and try to inject this one. Okay. What happens when we try to check the version number? All right. It's not working to show us the version number, but what happens if we output the file? If we output this to a file instead of trying to show it here? So let's output it to the root version.txt and then see if that file exists. Still gave an error, but let's see if that file has been created or not. Amazing. So yeah, it has been created. since we're able to create files, let's go ahead and inject a reverse shell. I mean a PHP shell, web shell. So I got it right here ready for us to use. Now, we're going to be injecting in the same location that the version to the output file worked. So in that, we're just going to be placing a PHP shell using the CMD as the parameter. And then we're going to access that file in order to access the actual host. So let's do it. Amazing. Wow, incredible. We have remote code execution. Awesome. So since we have remote code execution, and we know that this is a GCP instance, let's go ahead and try to access the metadata. So I'm going to take this curl command and we're going to go to Burp Suite, go to decoder, and if I paste this, this is the standard curl to get the metadata, to get the token for the default service account. And if I go to encode it to URL, whoops. Wait. So I have the encoded version right here. But before we get to that, I just want to explain something. So this is a service account that's assigned to the compute virtual machine. And by accessing this service account, we're going to be able to access whatever the virtual machine is able to access within the GCP environment, within the project that it's in or it's associated with. Now, usually, these service accounts are highly privileged. They have default roles such as editor. And that's why this is a high-value target for us to try to access. Now, I have the normal curl command. However, I need the encoded command, which is right here. This is going to be able to be, this we are going to be able to use within the curl command of our own host. That's why we need it to be encoded. Incredible. So we just got the token. I'm going to save it to a token file. And from here, we're going to run a couple commands. Firstly, we want to brute force our permissions. And we're going to be using brute force myperms.py, although you can use any number of permission brute forcing tools that are out there, including even the tool that Pwned has created, or rather Ian Austin. So whilst this is running, I want to explain how we attain the project ID. So the project ID is also attained through the metadata. For example, if we wanted to recursively list the entire metadata service, we can do so like this. So before I use the encoded version, I want to explain to you that we're using this parameter right here, recursive equals true and alt equals text. This is what's going to recursively provide us with the entire metadata service. Incredible. So once doing so, as you can see, we have a lot of endpoints here. And the one that where we get the project from is right here. The instance service accounts default email is going to include the project. The email of the service account is going to include the project, because the format of the service account email is firstly the name of the service account. So pose inventory at, there's always an at, and then the project name, grprod2. And then img service account stays the same across the different service accounts. So that's how we got the project name. All right, so we are 32% complete. Now, whilst we're doing that, let's go ahead and check for some other things. Another tool that I like to use is a GCP privilege escalation tool. So let's go ahead and see if we can run this bad boy. Unfortunately, we don't have enough permissions to run this tool. It seems like we might have to resort to some manual enumeration, but that's fine, at least until we get a good scope of what permissions we have. So let's go ahead and run some manual enumeration commands. So if you're not familiar, in order to utilize our token, we have to use this flag access token file and specify the token file where the token is inside. Incredible, at least we can do that. So one thing I want to do is I want to open this in Mousepad. And now that we're here, we can use the search feature to our heart's content. So let's go ahead and search pose inventory. So we see that we have Cloud Asset Viewer. And we also have storage.hmacKeyAdmin. So meaning we can create and delete HMAC keys. And we have a custom role as well. Pose role testing. So since this is a custom role, I have no clue what the permissions are for it. So let's go ahead and check that. Permission denied. So we're unable to list the roles, describe the roles of within the project. Unfortunate. However, we still got a plethora of information through this command. One other thing that I want to do is I want to take all the service accounts and make a simple word list of it. So because the format is kind of weird, I'm just going to make AI do this for me. Now, what I want to do with this list of service accounts from here is I'm going to brute force my permissions against all of them. Actually, now that I think about it, I didn't even check if I can just plain and simply list the service accounts. So let's go ahead and do that. Okay, so we can't list the service accounts, so at least we can extract the service accounts from the other command. Now, doing that, we have it ready for us for our trusty sidekick AI, ChatGPT. So let's go ahead and insert it here. Okay, now that we have that, I'm going to brute force my permissions against all of them. And I'm going to do that through this command right here. So as you can see, for our own service account, we're able to get the service or get the service account's access token, implicit delegation to our own account. It's not really delegation. And we can also sign JWTs, meaning we can get our own identity token as well. Unfortunately, we have no delegation permissions over any of the other service accounts. Let's go ahead and check if our scan for permissions is complete. Incredible. Okay, so it looks like we have the storage HMAC keys that we know of. We know we have these permissions due to the default role, the HMAC keys admin role. Resource manager projects get policy, we just did that. Recommender for cloud asset and a bunch of cloud assets permissions. Now, Cloud Asset can be used to display or list the resources of the project, like in a very effective way. I think in like a brute forcing way as well, but I'm not sure. So let's go ahead and use Cloud Asset. I actually labeled it white box method to see all permissions because you're not really going to be finding this role or permissions or set of permissions on any random service account. It's usually for a purpose. So let's go ahead and use the search all resources command, specifying the scope as our project, grprod2, and specifying that it's not a deleted object or resource, and having the format in the format of a table. And lastly, using our access token file. Okay, we got a bunch of stuff here. So it looks like we have the pose role testing. We have roles. And what else do we got? Ooh, looks like we got a function here as well. Cloud function. Export sales to GCs. Now, we don't have permissions to access the function. However, we do have HMAC And if you're not familiar, functions are created with a default mechanism, which also creates a bucket. In that bucket has the function source code. So if we find the source code of the function, we could probably get some disclosed information, data, or even move laterally to the function service account, if possible. So let's go ahead and see if this functions bucket is disclosed, although it does come with a default naming format, which we can guess. However, let's go to the bucket section and see what we got. Some routing resources, firewall resources, instance settings, and here we have some buckets. Incredible. Yep, so here is the bucket for the function source code. I know this because the source code bucket always has the same format, which is GCF sources, and then this number. This is going to be the unique identifier, the unique identifying portion of the naming scheme itself, and then the region, which you can brute force because there's only so many regions. However, what you can't brute force is this number right here. Okay, so we have this bucket right here, and put it over here, and then make a new tab. We have this bucket, and we know that we have HMAC If you're not familiar with HMAC it basically means that we can create an HMAC set of credentials, and then HMAC set of credentials can be used with gsutil for any service account that we desire. Why is this important? Because let's say that we have a service account that can list the objects of buckets or list buckets themselves. listing the objects is going to be highly valuable because, as you already know, we already have the name of the bucket. So if we have permissions to list the objects, we already have the target name. Let's go ahead and see if there's a service account that has this. So I'm going to search storage over here. Okay, so pose inventory, which is our service account, has storage.hmacKeyAdmin. Inventory storage has the role storage object viewer. Incredible. So this is the exact role that we were looking for. Let's go ahead and create the HMAC key for this account in order to use gsutil to access that function's source code. Create HMAC keys. Let me go ahead and paste this and then explain it to you guys. So we're going to be accessing this endpoint right here, the HMAC keys endpoint for our project, grprod2, using the storage Google APIs. And we're going to specify which service account we want to create the HMAC keys for. And that's going to be inventory storage, the one who has the role that can list the objects. And lastly, we are going to need to specify the token within the authorization header. Amazing. So we just did that. And we have the access ID right here. And then the secret right here. So these are our credentials for HMAC, for gsutil. Now, whenever we need to use gsutil, we have to set the pass credentials to gsutil to false. This disables passing the gcloud credentials to gsutil, because otherwise the credentials of gcloud will clash with the HMAC keys. And now, oh, we have to delete this file. What is your Google Access Key ID? It's right here. What is your secret access key? It's this bad boy right here. Amazing. So okay, so we cannot list buckets, but we can retrieve the objects of a bucket. So let's go ahead and back to this bucket right here and get the name of it and list the objects inside. Do not delete this bucket. Okay, so let's go ahead and do this again, but include the recursive flag. Incredible. So here's the function source zip. And but we also have the flag.txt right here. So let's go ahead and retrieve that to see if this lab is complete. Amazing, we retrieved it. Is this a real flag? Yes, it is. Incredible. So we could also check out the source code, but let's go ahead and plug this flag in and see if we just completed this lab. Amazing, congratulations. we have just completed this lab. That was incredibly fun and so much web application, but overall, an incredible lab. Tell me how you liked it in the comments below. Please like and subscribe and share it with your friends if you enjoyed. Please leave a like, and thank you very much. See you later.